We are now ready to analyze and try to determine how much iron is in our sample. To do this, we're going to use Beer's law, and we need to make standards like we did in our previous lab. In this case, all of our standard solutions will be made according to table 1 in your lab. We're going to first calibrate our spectrometer with a blank. The blank will have a solution of iron chloride, FeCl3, so this is iron 3+, along with some HCl, hydrogen chloride, and hydrochloric acid. And so the one part that the blank will not have is any thiocyanate. Potassium thiocyanate, KSCN, that's in our burette here, but we are not going to add this to our blank. We just want to make sure there's no color due to the iron and hydrochloric acid. As you can see, it looks pretty clear. We're going to add a little bit to our cuvette and use it to calibrate our spectrometer. Okay, now that our spectrometer is calibrated, we need to determine the best wavelength of light to use to absorb light for our sample. To do that, we're going to run a little test and determine lambda max, the wavelength at which absorption is maximum. So we have a test tube here, and in this test tube here is the same as standard number 2. It has some iron chloride in it and our hydrochloric acid. And we're going to add 5 milliliters of our potassium thiocyanate. And you'll immediately see the color change. In our previous lab, we used phenanthrene to react with iron to observe a color change. In this case, we're using thiocyanate. And the SCN- ion will react with the iron 3+ ions. And that will make this kind of pinkish or reddish colored solution. And we're going to just make sure this is mixed well. And then we're going to take a little bit of this solution and put it into a cuvette. And we're going to record the absorption spectrum for this sample and determine which wavelength is lambda max. All right, here's our absorption spectrum, and looks like lambda max is 473 nanometers. All right, at this point, we're ready to make our standards. In this case, we're going to make 5 standards. The 5 standards, 1, 2, 3, 4, 5, we've already added the iron chloride and hydrochloric acid according to table 1. And to each of these 5 standards, we're going to add 5 milliliters of our thiocyanate solution. All right, now we've made our 5 standards, and we're going to now make a test tube with our sample in it. So we're going to take 10 milliliters of our sample, again using a volumetric pipette to get exactly 10 milliliters. And to this test tube, we're going to add 5 milliliters of our thiocyanate solution, making a 15 milliliter total solution. And this is, in effect, another dilution step because we're going from 10 milliliters volume to 15 milliliters volume. can see that our sample has turned the same pinkish red color as our standard, so we definitely got iron out of our cereal into our solution here. And if we compare this to our standards visually, we can see it's not as dark as standard 5. It may look something around like standard number 4 in terms of its color intensity. We'll find out for sure when we do our Beer's Law analysis. So now we're going to take a sample of each of our standards to make our Beer's Law curve, and then finally we'll do a sample of our cuvette with some of our sample in it to figure out where it lies on that Beer's Law calibration curve.